module, you will learn about the molecular orbital theory. In an atom, electrons are present in orbitals of differing energy levels, such as 1s, 2s, 2p, and so on. They represent the probability of finding electrons around an atom. This observation led scientists F. Hunt and R. S. Millikan to develop the molecular orbital theory, which postulates that electrons in a molecule similarly exist in different orbitals, giving the probability of their presence around a molecule. However, for atomic orbitals to combine and form molecular orbitals, they must have similar energy levels and symmetrical molecular accesses. This means that even though 2px of one atom has energy equal to 2py of another atom, they won't combine as they don't have the same symmetry. The number of molecular orbitals formed is equal to the number of atomic orbitals in the atoms forming the bond. Electron distribution in molecular orbitals takes place as per the Aufbau principle and obeys Pauli's exclusion principle and Hund's rule. The electrons in an atom are influenced by only one nucleus, forming monocentric atomic orbitals. However, the electrons distributed in molecular orbitals are influenced by the nuclei of all the atoms forming the molecule, causing the formation of polycentric molecular orbitals. In an atom, the electrons present in the atomic orbitals are represented using the Schrödinger wave equation of wave mechanics by the wave function y, which gives the amplitude of the electron wave. However, the Schrödinger wave equation cannot be used for molecules, and hence a new method called the linear combination of atomic orbitals, LCAO, was developed. To understand this method, let's consider the hydrogen molecule made up of two hydrogen atoms, A and B. At ground state, each hydrogen atom has one electron in the 1s orbital. Let's represent their wave function as psi A and psi B. Now, there are two ways to add the wave functions. One is when these wave functions are in phase, either both plus or both minus. And the other is when the two wave functions are out of phase, one plus and the other minus. When the two electron waves are in phase, they form the bonding molecular orbitals. Here, the electron density is between the two nuclei. The electrons tend to hold the nuclei together, thus stabilizing the molecule. Therefore, we conclude that a bonding molecular orbital always possesses lower energy than either of the atomic orbitals that have combined to form it. When the two electron waves are out of phase, they form antibonding molecular orbitals. Here, the electron density between the two nuclei is reduced such that it is zero at the nodal plane. This leads to mutual repulsion of the electrons. as the energy of the mutual repulsion is more than the attraction between the electrons and the nuclei, the net orbital energy increases. Thus, the energy of the anti-bonding orbital is raised above the energy of the parent atomic orbitals that have combined, and the energy of the bonding orbital is lowered than the parent orbitals. However, the total energy of the two molecular orbitals remains the same as that of the two original atomic orbitals. You have now reached the end of this module. In this module, you learned that atomic orbitals of equivalent energies combine to form molecular orbitals. Two atomic orbitals combine to form two molecular orbitals, known as bonding molecular orbital, denoted by sigma, and antibonding molecular orbital, denoted by sigma asterisk. Linear combination of atomic orbitals, or LCAO, is an approximate method that has been adopted to explain systems containing more than one electron. The linear combination of atomic orbitals helps describe the formation of molecular orbitals mathematically. When a bonding molecular orbital forms, there is constructive interference because the two electron waves of the bonding atoms reinforce each other. The electron waves cancel each other due to the destructive interference in an anti-bonding molecular orbital. The total energy of the two resultant molecular orbitals equals that of the original atomic orbitals. A linear combination of atomic orbitals forms molecular orbitals only if they satisfy some conditions.